using. Let's go to. Have you used YouTube, Zoom for meeting?
Yeah, I did.
Oh, it's good. Good. Okay. So I will go to your email here. So you can also share your screen at any stage. Oh, your handwriting is good.
Thank you.
Yeah, mechanics. Yes, that's the main part of this test. Mechanics. Wave and optics. Well, relatively speaking, they are not not as demand as ATA, right? In my impression. Natural world, yeah, there are some common knowledges. Bear in mind, they have a tradition to look not just beyond the textbook. Yeah. You say the solar system, right? You didn't mention that. Yeah, the phases of moon, yes. Ellipse of various kind, yes. Understand term of satellite, geostationary. So geostationary, you know, can you guess? Common sense. Geostationary. Geo means Earth. Stationary is relatively speaking not moving. You know, your communication satellite must be stick at a particular position and they rotate together with Earth. Otherwise, they cannot maintain that coverage. Yeah, you have sometimes you have to use common sense, right? The phases, I would say, just I show you some picture. I will. Yeah, to answer the question, phases are just the different moons, the new moon and the various name for that. Let's just stop this. Still go to the website, go to this site. It's just 1 moment. Minimize that. So I'm going to do is show you another file. Yeah, that is a phase of the moon. Can you see that?
Yeah.
Yeah, it's just common sense, right?
Do they require to remember the name?
No. You probably they will say probably well if you can pick up, you know, say the new moon is dark. Well, not a big deal. I mean, when I was in high school, I can memorize anything, but it's okay. It's okay. Yeah, but don't worry, they are not very rigid. Okay, they are. I look at their text paper. They are very flexible. Meaning sometimes you have to use very different approach to this problem solving. Yeah, they are not, well, I noticed you have to memorize this basic formula, which are not a big deal, right? So I can send this to you if you wish, okay? This got some of the formula here. Can you say wave? Perhaps we could go through that. Anyway, we can discuss this later, but I will just return to your note first, all right? Let's just go there. What I'm going to do is where's my website? Stop sharing or I probably still need that piece of paper. Not here, sorry, where did I put it? Here. Here. Okay. Right. So what shall we start? You want to ask question or you want to give you the introduction? Friction. Do you know the difference between static and dynamic friction? Do you know the difference between the two?
No, we haven't studied that in QCAA. Okay.
We'll talk about that. We'll talk about that one thing. Air resistance is part of friction, which is basically talk about is air. So when an object, an airplane, move, relatively speaking, you say even in the static, you see, you know, the meteorology station, you see, they got the, airport, right? They got these various, you want to say bags, or say, so they can pick up the wind. So when the wind is, basically wind is a movement of air. Air is made by molecule. When these molecules interact with this air flying object or any object in the sky, they will behave like the boat experience resistance from the water. So after all, in physics, fluid dynamics covers all this scenario, if you want to say. So air resistance, water resistance, okay? Even in that kind of the category. So terminal velocity, have you heard of terminal velocity before? Or we can discuss this one. The terminal velocity is is kind of the dynamic balance. So when you know the parachute, right? Parachute jumping.
What is parachute?
Parachute is from airport, pilot emergency. They jump out with open the parachute. Parachute. So that is where you can see that they move very slowly, almost a constant speed. Without that big the materials, they should drop much faster. Free fall, you see, the free fall.
Yeah.
The free fall is just increasingly very quickly, but with that, because of air resistance. Oh, by the way, ordinary friction, air resistance in air, resistance in liquid, in air, are all called drag force. Drag means that there's something push you back, okay? But of course, if you're not moving and they stop, see? Can you imagine that? Air resistance is not constant. Air resistance is proportional to the how fast or the velocity of the object. Yeah. Okay, we'll talk about that. Okay, we'll talk about this first, okay? We'll talk about number 1 first. We'll talk about the friction. So let's go to the whiteboard. So that's how I tutor students, use whiteboard here. So the friction, so can let me know if too slow, okay? If you talk of frictions, probably we will start with the ordinary the friction idea. So we got object, even the horizontal one, and we were, for example, we got the contact at the surface, right? So surface of various kinds. Some are very smooth, others are very rough. Okay. So you can imagine that if you push for some, if you just put the force to put it forward, okay, you can put it forward. Can we put it forward? Yes, we do. So we can this just arbitrary force. Someone is pulling the box on the ground. So this is force F. I use this arrow bar to denote the vectors, okay? Yeah. Because that's very important to understand. So without assumptions, and there's always frictions because there's a contact, right? So I use different colors. So that is always force backward. Notice I use this arrow bar to always starting from mass center, okay? Because after all, we are not going to start with a shape, okay? We're talking about the shape just you mentioned the leveler, right? That otherwise we just assume every object is made by point mass. Have you heard of point mass?
Yes.
The point mass is ideal. So from this one, so this is ideal. So from this one, we can assume that we can describe this the force as a mathematical point, okay? And that is where this point represents the position as well as his mass. That's all. Yeah. Okay. So in this way, when we draw the force, so we prefer to just use this point. Can you see? I just repeated this two. The fraction is dragon force. Any other force involved in this scenario in general? Any other force other than the two we just discussed? Can you imagine any other force involved?
The direction that the object is moving.
No, here is object. By the way, this is Earth. Okay, without the specification, everything we study most scenario in the surface, near the surface.
Oh yeah,
Earth,
the gravitational force.
Yeah, that's right. Yeah, of the Earth, So hopefully this downward. Do you agree? Downward, so downward. So there's gravity. Yeah. So I do it side by side to make sure, because that is a good way to apply Newton's second law. Okay, if you draw everything, you don't have time. For example, you say the question says the bicycle, is doing what? You can't draw the bicycle, right? Yeah. So remember, when we study Newton's mechanics, we always use this ideal model, point mass. Okay. Any other force? Can you imagine?
No, the normal force.
Normal directional force, yes, which is upward. Okay. So this is, in this case, in this diagram, we only just work out the direction, all right? So unless they ask you to make sure the amplitude is correct, well, they will give you a number, all right? Otherwise, the direction is important, okay? So I put it one by one. So this is ordinary force. This is a normal directional force. This is mg gravitational force. This is fraction, can you see? So by definition, how do we work out the fraction? There are many empirical formula used in physics. You know, physics starting from empirical study. Do you know empirical?
No.
Empirical is just we see something where we say we make up something to explain. For example, obviously, for fractions, this is called a fraction. Fraction f is proportional to the weight, if you wish, of the object, the heavier because the push is down. So to be exact, the friction is always in this case proportional to the magnitude, not the direction, the magnitude of normal directional force. So if you know, if this is called the relation two variable in physics is called proportional, we can immediately write that as a constant, multiply this product. So that is fraction, can you see? So this new, this Greek called new is called the coefficient. Coefficient. It's just number, which allowed you to measure, to make experiment. We can measure the fraction, okay? So for each different surfaces, then these coefficients are different, right? And normally it's less than 1. So for example, that could be 0.3 or 0.5. Okay, you don't have to memorize that, but just give you kind of idea. They cannot beyond that normal directional force is always smaller than 1, sorry. Okay. So that is the formula for friction in this case, all right? Now, to be specific, that force have to be divided into the static and the dynamic, okay? When you say static and dynamic, what can you imagine? Can you understand what I'm trying to say?
Is it a friction occurred when the object is not moving?
So that's why this velocity equal to 0. So that velocity is not equal to 0. Now, when talk about another vector, that's the difference, okay? And just take this chance to give you the behavior of this relation between these two. And you would imagine that the air resistance, okay, that is, so the air resistance can have two kinds. One is a static. So static friction will behave like this, okay, see? If you don't pull or push, it's just 0, okay? If you pull and push, and that will increase, can you see? That will increase very quickly, okay? But at this moment, as we, by definition, the object is not moving. Once object is moving, and that will go to the dynamic range. You see. So this, so you can say this is a proportion to the force, okay, along the direction. If this, can you see? If this is theta, this is f cosine theta. Can you follow me? Projection, horizontal direction. Let's slow down a little bit. So if you
I don't quite get the part where the
so basically you have the object, you see, is object, okay, change the color a little bit. So you want to move that, okay, you have either push or pull, right? Okay, imagine you shopping, right? You have to pull the trolley, you have to pull, right? Or push, do you agree? So you push that. If they're not moving, and the resistance will build up depending on the force. So therefore, the force will increase. Can you see that?
Yes.
But once we reach to this point, so this is a two regions. So this is a velocity. So these regions velocity equal to 0. Can you see? So reservoir velocity is not equal to 0. Does that make sense? Yes. So if the force is strong enough, the object will moving. Okay. So sometimes we have to specify this is a dynamical. This force for dynamical. Okay. So when the object is moving, which is more often the case, all right? And that is the difference between dynamic and static friction. Okay. Now let's go to, if we just use this idea to talk about, let's go to next page. And if we just talking about, let's go to air resistance now, right?
Yeah.
So imagine that the air is, although it's invisible, right? Although air is invisible, we can imagine there's some airs in the atmosphere, right? And so if the object is dropping, you see, or is moving, anyway, can we just talk about free fall first? Yeah. So if the object is dropping, this time I use the velocity, okay, the downward, right? So this is a downward, is represent the velocity of this object with mass, okay? Now in this case, because of air, so therefore, if you just enlarge this part, so if you enlarge this part, the air will collide, can you see? So the air molecule in front will collide with the surface, all right?
Yeah.
And also, that if that is, this is R, so the largest area, the cross section, do you know how to a cross section? Have you heard of cross section?
No.
So you just
so it has larger surface area.
Do you cook? Okay, so this is a tomato. Okay, you just cut. You will see the circle. Can you see? That is cross section. That's called cross section. For example, if you have the when you study electricity, then if this is a wire, can you see? You can imagine the charge is moving, right?
Mm-hmm.
You can also imagine there's a cross section. That is how we use this cross section to define the current. Can you see? You will see how many that cross section is this is a cylinder, can you see? And for the sphere, the cross section is also a circle. In both cases, are the circle. So that is so the cross section we just use A, that will be equal to pi r squared, right?
Mm-hmm.
So people know that the friction. So as a whole, because it's collide, okay, object, you like, so some will go away, you can see that will go. They have basically there are four of the molecule here. If the object wants, like you work in a very crowded, after the cinema, if people want to go out, right? So you will be slowed down, right? You cannot fly, you cannot run. Do you agree?
Yeah.
Because of this surrounding. So therefore, so the friction force is similar to the friction between two surfaces is the same. It's always opposite. Can you see?
Yeah.
Opposite to that. Now this force is determined of air resistance. Okay. So that's called air resistant.
Mm-hmm.
So this type of dragon force, dragon force, is someone drag you.
Yes.
Dragon force, it's called dragon force. Or stop you or slow down, right?
Mm-hmm.
It's called the dragon force. So the formula is that, so basically, of course, the force is air force is proportional to the area, the crossing area. Can you imagine that? That's why, the parachute, the larger the area and the slower the jumper will move downward. Does that make sense?
Yes.
Yes. Can you imagine if you just, for example, the jumper forgot to open or failed to open the parachute, he will be in trouble. Do you agree? Because if you fail to open the parachute when you are falling, and the air resistance is much smaller.
Yeah.
Okay, so that is some first idea. Air resistance were proportional to the cross section. Okay. Another is that air process is also proportional velocity. Okay. And also in some cases, people found it's also even proportional to this velocity square. Can you follow me?
Yes.
Because the faster you move and the more air will collide with you, although they are very small, but cumulatively, when you put them together, that resistance is very strong. That can actually make the airplane fly, right? So strong. So if you put these three scenarios together, then we can obtain the formula, okay? This is not a basic formula, okay? In physics, there are two types of formula. One is a basic law, like Newton's second law, gravitational law, Coulomb's law, and Joule's law, not Joule's law, but others just empirical formula, okay? So in this case, the force can be simply written as, we can use any letter, okay? I use a Greek letter called kappa. You can call it K, doesn't matter. But I just want to differentiate that K. K we use for ordinary friction between two surfaces, okay? So that is a formula. So that is this is a formula for air resistance formula. Any question?
Is it just KV?
KV, yeah, you can call it K.
But isn't it related to the cross section?
K will depend by cross section, yes. Because we can, there are other factors other than the cross section, they also have the shape, okay? If you use a different shape, you drop the different shape, right? If you do different shape, and the resistance will be changed.
Yeah.
You know, the race car, you see the car for race car, they call a streamline, okay? They got a streamline. So therefore, the cross section may be the same. However, because they have their streamline, so therefore the air resistance will decrease. So you can, good idea. So this K, the kappa with the constant, kappa will be determined by many factors. The cross section, the shape, you see?
Yes.
And so on. So that is a K is just, that's what we call the empirical formula.
Yeah.
We only do it by measurement. There's no theory to predict, okay?
Mm-hmm. So we might not be asked to like actually calculate it, or they'll just be giving the K value.
The worst, this challenging scenario is just to say, well, given that we're mentioning the terminal velocity now, given the terminal velocity, how can we work out the air resistance coefficient? They might ask you what the K is. You see, question can be asked forward, for example, right?
Yeah.
So forward question is given F and K, what is V, all right?
Mm-hmm.
Or you can book it back, you can ask backward, can you see?
Yeah.
So that is a type of exam question, see? Forward, backward. Now return to this diagram. Because this velocity is a proportion to velocity, the velocity, okay? So maybe we can find somewhere to draw this graph. So you tell me, so how can we draw this graph? Graph is very important. So this is F, air resistance.
Mm-hmm.
You don't have to, you just call F, is okay, but in the context, people know what is. So this velocity, based on this formula, can you draw the graph? Can you draw? Do you know how to draw from your side?
I don't think I can draw.
You can choose the sharing option and choosing and yes, good. Okay, they may ask, you know, so given this alpha equal to 30 degree, okay?
Yeah.
So what is the K? What is the kappa?
Oh.
This question can be a little bit of math as well.
So K equals F over B.
F over B, yes, that's the kappa, yes. Yes, with that, yeah, that's linear function and quadratic is also part of this test, right? So it's
sorry, there's a bit of lag.
Yeah.
So how is it related to the angle?
Well, basically, I gave you a little bit of math here. So if you have if you start a linear function, right? You start linear function. So this linear function could be a straight line, which not necessary through the origin, right?
Mm-hmm.
So that is called a linear function, right? This is y, this is x, right?
Yeah.
So for this function, what is the general form of this equation?
Y equals mx plus c.
Yeah. Can we just use the ax plus b? Can we?
Yeah.
Doesn't matter because it's algebra. Okay? You can use A, B, C, any letter. So that is the form. Okay. So we know that A is a gradient or slope, right?
Yeah.
So how do we find the slope? We can either we can solve that if we know B. Okay. If we know B, can you solve X? Can you solve A? Can you? Yeah. Can you try? I just look at how you dealing with algebra.
So if we are given B.
Given B, yes. Yeah. Given B, yeah. How do we determine slope? How many methods do you know? Yeah, correct. So good. So basically, that is one way to do that. All right. Another way is that we use calculus, right? We use calculus. We just use a dy dx. What is dy dx?
Yes.
It's A. Can you see? So there's a second formula. There's a second. Okay. Now, because it's a straight line, this A must be the constant everywhere. So therefore, given this alpha, we know that we could do tan alpha. Can you follow me? Tangent. Sorry.
Yeah, I can't picture the triangle.
tan alpha. Okay. Now this is just the calculus. Have you started calculus? Yes.
Sorry.
Calculus. First derivative.
Calculus. Yes. Yeah.
Yeah. So this is first derivative, right? That's the first derivative.
I just don't get why is it 10.
What is tan alpha? The third equation. The third one, probably in year 10 or 11, teacher shows that the K can be written as y2 minus y1 divided x2 x1. You know this formula?
No.
Or delta y, delta x. Wow, you have to pick up this one. Very useful. You see? You see? So there are three ways to determine the constant. Now, this is very useful in solving.
Yes, that one. I know it.
Yeah.
It's rise over run.
Yes, rise over run. Rise over run. Yes, that's another. That's for the beginners. That is rise. Okay.
Yeah.
Rise and run. Yeah, that's right. Okay. All right. So that is how we relate it. So any formula. Now return to the formula we have here. This kappa will simply equal to tan alpha. Can you see? So in this case, we can argue that K will equal to tan 30 degree. Can you see? Whatever, you can use calculator. So you can calculate.
I got it. Yeah.
You got it? So this is a way to ask you a question, how to determine the coefficient. You still can call it a coefficient, okay? Any number you can call the coefficient. Now return to this diagram. So you can imagine that if the airplane is moving, so for some air shown, and they jump. They were not open the parachute for a while, okay?
Yeah.
Until last moment, okay? They open that, okay? So during this time, you can see that the velocity. Can we just call this time 1? So this is t equal to 0. Can you see? And this is open the parachute, and between that is this T1, okay? And the landing time is T2, okay? That at the time T2 they landed. Now, can you imagine that what is the dependence of velocity as a function of time? If I draw this graph here, let's draw this graph here very close. You can compare, and you know what I'm talking about. So if I just draw this diagram. So this is I'm talking about the velocity of the parachute, okay? So this time 0 here, the time t here, the jump, okay? The jump. And then after a while, they start probably was the T1 and the T2 and they landed, okay?
Yeah.
I just remind you that at the beginning that the parachute over here, right? The velocity is velocity is 0 because the airplane is not vertically moving. I'm talking about downward velocity.
Yeah.
Velocity, airplane goes that way. So at the beginning, the velocity is 0. Okay. And when of course, when it touches the ground, the velocity became 0. The question is, what is the dependence? Can you guess during that T0 and T2?
What is dependence?
So how do we draw the graph to find the dependence? So that is a terminology we often use. So for example, let's go to this page. So in this case, we say that, so in this graph can be interpreted just, so when we see this phenomena, we will see y is linearly, in this case, because straight line, EAR, dependent of x, or you can say y depend on x linearly.
Yeah.
Can you see? We have different phrases. Understand? Dependence means that y is a dependent variable. Okay.
Y changes while x changes.
Y change because of x change.
Yeah.
Where x is called independent variable.
Okay.
Okay, that makes sense now?
Yes. Yeah.
So that is the bit of the mass variable. Okay. So
yeah.
Therefore, we say, when we say, can you draw the dependence, which means we just draw the what kind of function? The graph, you can, it doesn't matter, you can try. Maybe they will increase, all right? Or they will decrease, or probably more complicated than that. Can you try? Can you try?
Yeah, I think it rises and then it stops at a constant velocity.
Good idea. Yeah, good idea.
And then it decreases.
Yeah.
After landing. Yeah.
Linearly.
Curve.
Yeah. So the first part is correct. Why don't you borrow the same idea? Why don't you borrow the same idea to the second phase? Why do you? You're right. The first rate is the perfect. But so they open the parachute, okay?
Yeah.
So at this moment, they open the parachute. When they open the parachute, so the parachute the air will increase. The resistance will build up. They cannot go linearly. Okay. And try again. The first phase.
Trying to wrap it up.
Okay. You can just redo, undo.
Like this.
Oh, here, perfect. Now, here we got 2 terminal velocity. That's why. You see, the first terminal velocity is this one. This is terminal velocity. Okay, T1. Okay, another one in this part, the smaller. Can you see? Much lower. Can you see?
Yeah. The
second velocity is much lower, so therefore it's safe for people to landing. All right. The first terminal velocity is large because basically this guy is just almost like free fall, right?
Yeah.
But unlike, because when we talk of free fall, you have to be careful. When free fall in vacuum, then that would be like they just increase. However, this is not free, so this fall is not free. Okay, not free. So this is no longer free, not free fall, because there is a air resistance built up proportional to as it shows in this diagram. Okay. According to Newton's law, when you say the velocity is constant, what conclusion can we obtain?
Constant acceleration.
Are you sure?
When the velocity is constant.
Let's draw another. It's a bit crowded here. I draw another diagram for you.
Okay.
Now, you're right. So the first stage that they will build up like that, and then they will build up another terminal velocity. So the question is, how can we determine these two terminal velocity? Can we call the T1 here? There's a terminal velocity. It's called the VT2. All right. There's a time. The T1, T2. You don't confuse with the T. T for time. This is T for terminal. Okay.
Yeah.
VT for terminal. Terminal. No. Okay. So, because in this case, we will see that the constant velocity appears. According to Newton's first law, what conclusion can we make? So this is a VT1, this is VT2, two terminal velocity. This is a velocity of object.
What was Newton's first law?
Aha.
I don't remember.
No. Yeah, it's very, so that's the first law. The first law, also this is the first law. First law is called, give you the hint, inertia. You know the inertia?
Yeah.
Inertia means that any object has a mass where resistant the change. Do you understand?
Yes.
For example, if you take a bus, all right, a school bus, and what happens if you just stand there, okay, and the bus suddenly stop, okay, slow down. For example, there's something there, and the driver started to stop. So what would happen to this guy?
Keep moving in the direction.
Keep moving. Yes, that will be a very dangerous scenario. Do you agree? Yeah. If no seat belt, then they will be maybe hit hard badly. Okay, will be hit badly. So that's why when object, because obviously this person have mass, right? Yeah. According to the Newton, inertia is proportional to the mass. Okay. The larger is object, the larger the inertia. Okay. Mm-hmm. Otherwise, if there's no force, of course, eventually they will stop. Okay, or even they will collide with the bus itself, right? Mm-hmm. But if there's no resistance, what would happen to this when cars, if there's a window, for example, the car is open, can you see what would happen?
Slide out.
Oh, they're just flying, okay? Yeah. Keep the same distance, right? Of course, in real world, we have considered air resistance, so they will sooner or later will stop, okay, even in the surface. Anyway, Newton's first law, Newton has 3 laws. What is second law? Do you know?
F equals ma.
Yeah, that's very important. That is F is a force, the net force equal to ma is okay. How about the third law?
Like when you throw an object away, the object throw you away.
Well, if you use a notation, that would be like this. If this is two object 1, 2, I use this notation for the force. That is a 2, 1 equal to negative. That's Newton's third law. Yeah. What does it mean? So if you have 2 objects, right? Object 1, object 2, okay, and when they collide, they will bang. So what happens? The force of object 1 experience the force come from 2. At the same time, the object 2 will experience the force from object 1. However, these 2 forces are opposite in direction, right? Yeah. But the same, but identical in direction. Yeah. Can you imagine the consequences when they collide? So this is that is Newton's second law. It's a third law, right? Mm-hmm. That is all about the Newton's mechanics. Okay. Anyway, first law say, however, if there's no force, like if you go to even start from second law, if the net force on the object equal to 0, so the logically we say the A will equal to 0. Do you agree? Because this is FA equal to MA, all about. Yes. So therefore, we can say by definition, A is equal to the initial velocity delta V, delta T. Can you see? Yeah. Roughly, if you have studied calculus, we have used this formula, all right? They maybe ask you to use this formula to calculate the velocity or acceleration. So according to this one, we can argue that in this case, because A equal to 0, though, so the delta V will equal to 0. Okay, so what does that mean? The delta V equal to 0. So velocity is a constant. Can you see?
Yes.
This is a forward application of Newton's law. All right. If we go to backward, if the velocity is constant, we can conclude what?
The force is constant.
Are you sure? No, we just go move forward first. Okay, move forward. Yeah. Can you see? If move forward, we say this is this condition. Okay. That gives the condition for this one. Can you see? And that gives this forward.
Yeah.
Now, if we go backward, should be the same. Do you agree? The conclusion will be the same. Can you see? It's called backward.
Yes.
So if you see the constant velocity, or you can see the horizontal line, or this by the way, this very important graph is called the velocity time graph. Have you seen that?
Yeah.
Velocity time graph. It's very important. Some called diagram, I call it graph. Okay, which means that the dependence of velocity on time. Now, if you say horizontal part, you know that in this case, the total force is equal to 0. Does that make sense? The force, the total, the sum of vector force acting on object vertically must be 0. Does that make sense? What when I say the total force equal to 0, what does that mean?
The object is not accelerating.
So yes, you're right. We know that acceleration 0, so they are all equivalent. Okay. When you say any of these conditions, you can conclude the rest. Okay. For example, you say acceleration, total acceleration is 0. Then we can say, well, the total force is 0, and also the velocity is constant. So these 3 statements are equivalent. Okay. Okay. Now return to our question. Well, today we're going to introduce a terminal velocity. Okay. Now, how do we work out the force acting on this falling object? Okay, I'll make it larger, but we don't have to. As I say, this is a point mass. How many force acting on that? Can you tell me?
2.
What is downward one? Gravity.
Yeah.
Gravity, yes. It's, and vertical. This is upward friction, air resistance. Okay. Now this time to use our formula. So the if we just use amplitude, this is just amplitude. Okay.
Yeah.
When we, according to Newton, in this region, okay, when the velocity reaches to a constant, we know that according to Newton's law, the Fa plus mg must equal to 0. Do you agree?
Yes.
Now, if we choose this direction as a positive, so that's how we choose that. If we choose any direction, is a positive, right? Or upward, doesn't matter. If we choose this as this x is a positive, then with this vector, this formula can be written as negative Fa plus positive mg equal to 0. Can you follow me?
Yes.
So this equation is called the scalar equation. Scalar, you know scalar equation? They're not vector, just number, but sign. And this part is called the vector direction. Okay. Yeah. So remember, Newton equation is in general must be written as a vector form. Okay.
Yeah. And
at this particular case, that we can argue that the Fa must be equal to, let's just use F, use a small a, you get confused, right? If you're a tiny a here, must equal to mg, do you agree? Can you follow me?
Yeah.
And at this stage, we can use introduce the terminal velocity now, must equal to mg. Okay, finally, what is the formula for Vt?
mg over k.
Yes, yes. Okay. That is terminal velocity.
Yeah.
Does that make sense now?
Yes, it does.
This is a formula you can apply, and it's easy to if you forgot, you will always go to this one. Can you see?
Mm-hmm.
You can go to this equation, all right? So, question, any question?
For the force diagram, does it not consist of any normal force, like when it's resting on the ground?
Well, force can be divided into two categories. One is a contact force, another is non-contact.
Okay.
Tension, normal force, these are all inelastic force, they are contact force, okay?
Yeah.
So there's another category, you can, good question. So the force, oops. So in terms of a force, it can be graphed as contact force, not physically. The contact is just descriptive, okay?
Yeah.
The contact, physically contact force, and it gets a non-contact, okay, non-contact. Or sometimes called the field force, like an electrical force, no contact, do you agree?
Yeah. Yeah.
That is a force. So that, how many contact force? Normal directional force, okay? Normal directional is part of inelastic force, okay? Because elastic, okay? That called, the spring elastic. We're talking
No,
about
I haven't learned.
Yeah, spin force. Or this, because another is just normal directional force.
Mm-hmm.
Normal directional force. Okay. And the contact force also the tension, because normal force is the tension. For example, if you hang an object, right?
Yeah.
And it got a weight here.
Mm-hmm.
So this part, we just here I simplify this as a point mass. You got downward gravity. And in this case, what is upward force? Can you tell me?
Tension.
Tension, yes. Tension is contact, okay?
Yes.
Without contact, doesn't exist. As simple as that, all right? Okay. So that is a contact force. And also friction is also contact. Without contact, you cannot, there's no friction.
Yeah.
Friction, you can put in this category. Okay. Normal non-contact force include gravity. Okay. Gravity. Okay. As long as near the surface or near the object, they have gravity. And it goes to Coulomb's force. You know the Coulomb?
Yes.
Coulomb force. And also Lorentz force. You have you seen Lorentz force?
No, I think I'm learning that soon.
So that is that magnetic force. Okay, magnetic force. Okay, magnetic force. Have you do you know this formula? Say the force of equal to Q multiply E.
Yeah, I think so.
Good. Okay, another force I'm talking about, Lorentz force. This is called the Coulomb. This is called Lorentz force is equal to Q V B sine theta. Have you seen this formula before?
No.
Maybe we need to pick it up, right?
Yeah.
Okay. So we today we just covered this.
And I still have a question about the free fall concept.
Free fall. Okay.
Yeah.
Yeah.
So would there still be a terminal velocity if there's no air resistance?
Good idea. Good idea. Do you think so? If does the terminal velocity exist?
Can I see the formula again?
Yeah, we'll see the formula. So we know the condition that the terminal is reached, that the frictional force, air frictional force equal to mg, right? And if you rewrite that as the kappa is constant, that's velocity, all right? So that is mg. Do you agree?
Yes.
Now, if k equal to 0 or v equal to 0, this part will be equal to 0. So this you cannot use the condition anymore, okay?
Yeah.
You cannot use this condition. So that is why, yes, Newton's law, the free fall, like have you started using this formula? So that is S equal to half G T squared, right?
Is it kinetic?
No, that is a
No,
kinetic.
it's
That
not.
is I don't know where have you started. So if we start objects moving, we just go to horizontal direction. Okay, it's easy to. So if you go to, or we can go to free fall direction. This is have you started inclined motion?
Yes.
You must have studied this part. So inclined motion, and so in this case, and if the constant, if A equal to constant, okay, if A is a constant, positive or negative, then this formula, for example, basically we need to know the position of this object at any time, right? So the position, the displacement, this is called displacement, were equal to some textbook use S, all right, for displacement. But bear in mind, is this formula is for the displacement. So this is a delta x here. It's called displacement. Can be written as ut plus half at squared. You know this formula? Yeah.
Yes.
Good.
So
another formula is that is another formula is for velocity. The final velocity equal to u plus at, all right?
Yeah.
And of course, the third formula is v squared minus u squared equal to 2as. So s is a displacement, all right? If you apply this formula to the free fall, return to your question, free fall, which means free fall only have gravity, okay? Actually, the ball is not free because they're attracted by the gravity, by the Earth. So when the free fall, depending on how you choose, so in this case, A is either equal to G, you see? A equal to either equal to G or A equal to negative G, depending on how you choose the direction, right?
What does A stand for?
A is acceleration.
Oh yeah, okay.
We got acceleration. So basically we got, can we start from velocities? Can we, so when you describe the motion, one we need to know is position, okay?
Yeah.
We use X as time of function of time, right? Then we need to know the velocity. Okay, that is V, okay? A third one is acceleration. Yeah, very important. We need to learn acceleration because without starting acceleration, the velocity, we can only start constant velocity. Okay. Now, the relation between them is this called dx dt. Can you follow me?
Yes.
Is dv dt, or have you started second derivative?
Yes.
dv dt squared. Okay. So the reason we need to know A or acceleration because according to Newton's law, once we know the total force or net force, okay, we should be able to work out the A, you see.
Yeah.
So that is all, everything in Newton's mechanics is about how to determine the total force or net force. It's called the net force because of summation, okay. They call the total net force. If we know the net force, then we can determine the motion. Does that answer your question?
Yeah, I just didn't realize A means acceleration.
Wow, you miss if you don't pay attention to A, you miss out of the essence of the mechanics. Yeah. Okay. A is a pivot. It's very important. So it's a result is a foundation of the Newton's law. See, when the first law actually stay, the acceleration equal to 0, what would happen? If the acceleration is equal to 0, we can make two conclusions. Either the object is to keep the constant velocity, or still stand there, stationary. Okay, so it's just. Can we return to your question note? So it's so we know the friction, air resistance, terminal velocity. How can they calculate it? We have done all of them. Do you agree?
Yes. For the last question I was actually asking that if there is an acceleration, there is gravity, but without air resistance.
Well, you see, we in physics we always assume that we just assume that the condition is simpler. Without the air resistance, how can we get the resistance in the first place? Is that your question? No.
Sorry, can you repeat?
So air resistance arising from the existence of air molecules, right?
Yes.
If we assume there's air, either the density is very small and therefore we can omit the resistance. So that will return to the formula we outlined to you, that the displacement will proportional to half g times t squared.
Yes.
Go to there. Go to the whiteboard here. Can you see? For the free fall, I think that is are you looking for this? We don't have, in this case, we don't have to consider the air resistance.
Yes.
Okay? Because if the air resistance, we still, sorry, I'm wrong. So basically, if the air resistance is not there, we can simply use this equation. Otherwise, can we just give you the formula here? If the air resistance is still there, what would be the case? Good question. Can you see? So we have to consider this equation. I don't have to repeat that. This is a force. Can you see? Can you see this force here?
Yes.
Right. Unless before in this region, can you see? Before they reach to constant velocity, and the acceleration is changing, okay, not equal to the gravitational, not equal to 0. So in this region, so this is in this region, the formula we have to use is this. According to Newton's law, the formula must be used negative. This too crowded here. We have used a negative FA plus mg equal to ma. Do you agree? We have considered the acceleration in this region. Can you see? Or this region. That is what is Newton's law, second law, all about.
Yes. Yes.
Yeah, makes sense. So in general, so when we apply this the flying object, okay, we just have two scenarios basically. We have either got the just gravity, okay, or we could got the both gravity and air resistance. Do you agree?
Yes.
So in this case, we can write a general formula for that, which is this is FA, this is mg. So according, we can work out the net force here, the total force, if you wish. That is mg plus FA, right?
Yes.
And if you just write, if you choose, for example, this time I choose this direction is positive, right? So then we got a negative mg plus F. Can you see that?
Yes.
Well, according to Newton's law, that must equal to ma. All right. So in this case, A acceleration is equal to F divided by A. Can you see? And plus minus G. Can you see? Divided by M. Sorry. Divided by M. Just algebraically solve this question. Can you see?
Yeah.
So in other words, if the object haven't reached the constant terminal velocity, I'm talking about the presence of air resistance, right? And the total force is not equal to 0. In general, it's not equal to 0.
Yeah.
However, if the object in this diagram, they have reached to the constant, can you see? Then we can safely say the total force equal to 0. Therefore, resistance acceleration is also 0.
Yes.
Does that make sense?
Yeah, so without air resistance, the person will just constantly falling.
Yeah,
without,
according to this formula, constantly accelerated.
A constant accelerating,
Yes,
but
yes.
increasing velocity.
Of course, very faster. Yeah, very quickly. They increase very faster.
Okay.
So if you can use a high-speed camera, you can see if this is falling. So the first second, the object will drop that much. Okay. The second will double. This 4 times. You can see, and the fourth, and then afterwards they will just go to that. You can see. So that is 1 second. The first second, the third second. The velocity will build up very quickly without air resistance.
Okay.
Yeah.
So it just constantly increasing to infinity.
Yeah, to be exact, the velocity will increase with constant acceleration equal to g. Yeah. Yes, you have to. So when you study physics, you have to use very economical about how now wording. Okay, you have to precisely point out. That's why I think this type of test will ask you many concept, the idea. Okay, so please pay attention to the meaning or definition of each quantity in physics. So what do you think? Can you follow me?
Yeah, I think that's pretty good.
Good. Can you say? Well, we'll probably we'll see. So did you say you wish to have more than 1 lesson per week, or
yeah?
Can we?
Yeah, I think 2 lessons a week is better.
Stop. Yeah,
than
stop
just
here.
1.